Hello. Journal number 24 is what we're talking about today. This is getting you ready for the Unit 1 test, which is going to be on experimental design and our first couple sets of notes on matter. So, you're going to put in your first and last name and then click the radio button for whatever period you're in and then click next. And the question is about the difference between the Bohr model and the modern model of the atom. And I've given you a little picture here to kind of jog your brain because I know it's been a little while and Christmas break and all that. But remember these? I say Bohr, you say ring, right? I say modern, you say Schrodinger. But three-dimensional is also the thing that we need to think about here. All right, so the question is, what's the big difference between the Bohr model and the modern model? And then why do we still use Bohr's model if it's not the best one? So, the reason why we say it's not the best, well, if the modern model improved on Bohr's model, then it's better, right? Well, the modern model is better because it's more accurate. It accounts for the three-dimensional nature of matter. If you were to take Bohr's model here and think about it in a three-dimensional nature, take this model and turn it on its side and rotate it around, it would look more like a fried egg, kind of a little thicker in the middle and then thin on the edges and then, kind of flat almost. And matter is not flat. Matter is three-dimensional in nature. So if you take this modern model and flip it around, it looks the same, no matter how you're looking at it. It's a sphere. It's like, hang on a second. Okay, so I don't know how well y'all are going to be able to see this. Does that work? Maybe, sort of. Okay, maybe this would be better. I don't know. I can't tell. I'll try it both ways. So an atom's more like this, three-dimensional. Now, this, of course, has a stylized universe in the center of it. I think probably you can see it there. And, that would be kind of like the nucleus in the center. And I mean, honestly, if an atom was this big, you still wouldn't even be able to see the nucleus. It would be that small. But anyway, but it's three-dimensional. I can rotate it around and it's a sphere. And this is more like what an atom is like, where in the center there, do you see how when I turn it sideways, it's flat, but when I turn it this way, it's right? So Bohr's model is more like the universe that's inside here. And that's why Bohr's model often gets called the solar system model, because it looks more like our solar system with the nucleus as the sun in the center and then the planets surrounding it. So, you know, it's not accurate. But can you imagine trying to teach electron energy levels and all of that stuff using this model? It would be impossible. So we go back to Bohr's model to teach those things because it's a lot easier. It's a lot easier to teach it when you have Bohr's model. So basically, the big difference is three-dimensional versus flat. So the modern model is better because it is more accurate. It accounts for the three-dimensional nature of matter, where Bohr's model is flat. I'm going to put flat in. It's not really flat. It's more like a fried egg, but it's almost flat. So we're going to go flat. We still use Bohr's model because it would be difficult to discuss and, I don't know, demonstrate electron placement without it. There we go. All right. So just a moment and we'll have the whole thing posted for you to be able to look at. All right, so there it is. The modern model is better because it is more accurate. It accounts for the three-dimensional nature of matter, where Bohr's model is flat. We still use Bohr's model because it would be difficult to discuss and demonstrate electron placement without it. Now, of course, that's Ms. Harris's words. You may use your own. Ms. Harris was usually a little extra, but you do need to answer both of those questions. You need to talk about the fact that one is okay. Y'all have a lovely day. I hope you had a good holiday season and a lovely new year. Bye.